So now I'm going to discuss about properties of logarithms. Now let's learn a few properties of logarithms. First, if the base of the log and the number that the log operate on are the same, this will always be 1 because anything to the first power equals itself. If, in- if instead we are taking the log of 1, this will always be 0, regardless of the base, because any base must be raised to the 0 power to get 1. Another important property is that log base b of b to the x is always x, since this can be expressed as b to the x equals b to the x. So, when you see the log of an exponential term where the bases match, it all goes away and we are just left with the exponent. Similarly, b to the log b of x also equals x because this log represents the number b must be raised to n order to get x. So if b is raised to that numbers, we must get x. Now, let's learn some properties that will allow us to do operations with logarithmic terms. These properties will correspond to properties of exponents that we already know. For example, we know that x to the a times x to the b equals x to the a plus b, which allow us to combine terms, or split one term up into two, because logarithms are as essential exponents, then it should follow that for any base, including base 10, which we will assume for the time being. Log of AB equals log of A plus log base 10, which we will assume for the time being. Log of AB equals log of A plus log of B. That means we can take something like log of 10x and turn it into log of 10 plus log of x. Log of 10 is 1, so this becomes log of x plus 1. We also know that x to a over x to the b equals to the a minus b, which again can be used to expand or condense certain expressions. Therefore, it is the case that log of a over b equals log of a minus log of b. This means that it is something like log of 3 over x. We could express it as log of 3 minus log of x. Next, we can remember that x to the a to the b equals x to the a times b. The corresponding property for logs tells us that log of x to the a equals a log x. So, if we have log x squared, that is the same as 2 logs x. Let's quickly mention that this only applies if the exponent is part of the term that the logarithm is operating on. If we had log of x quantity squared, that just means log of x times log of x. Just as with anything else that we could square, this is not related to the property we are describing. When this exponent is in here on this x term, it means that we are taking the log of x squared. And it is in this case that we can pull the 2 over to the front and get 2 log x. So these are the 3 ways that we can expand logarithmic expressions. They are the product rule, the quotient rule, and the power rule. Now that we know these rules, let's practice a bit. Try log base 4 of the square root of x over 16y squared. The first thing we notice is that we have a quotient, so let's break this into log of root x minus log of the y squared. This second term has a product, so we can expand again, but we have to be careful about our sign. To be safe, let's put this term in parentheses first. After expanding, we get log 16 and log y squared. Now, to get rid of the parentheses, we have to distribute this negative sign. So both of these terms become negative, and we are now done this step. We can actually simplify further starting on the left. Let's rewrite root x as x to 1/2. We know that we can pull exponents to the front, so this becomes 1/2 log x. Then, log base 4 of 16 is 2, because 4 squared is 16. So this becomes minus 2. Lastly, we can pull the exponent to the front on this last term to get minus 2 log y. And there is our expanded expressions. Let's take some other expressions and see if we can get it condensed into a single log. How about 2 plus 2 log x? If we want to combine this into one term, we need sign on each term, so 2 has to become a log. The other log is replied to base 10. So how can we express the number 2 as log base 10? Well, 10 squared is 100. So log of 100 is the same as the number 2. That gives us log of 100 plus 2 log x. Now, just the way we can bring an exponent to the front, we can push a coefficient up over this term. So, 2 log x can be log x squared. And now, we have a sum of logs with the same base, so we can combine them to get a product. And log 100 x squared is what we get. So, that would be all for this video. So,